Okay. Dangal greetings everyone. This is our midterms group research project.
For our problem analysis, we will be using two steps to accomplish this task. Step 1 is to identify and define a problem. The problem is to make and develop a simple automated toll booth simulator that will allow vehicles to pass and calculate the total amount collected for each vehicle type. After making the first step, we need to decide a solution for that. We will make a program that will implement and initialize the total amount of vehicle types and their toll fees, and ask the user to prompt a number of vehicles to process so that it will read and store the number of vehicles, and also check if the number is less than or equals to 0. The program will use a loop structure through the numbers of vehicles. It will display the process and ask the user to input a vehicle type from 1 to 4. Then after reading and storing, it will update the total amount based on its types. After processing all of it is to display the toll fee collected. The program will ask the user if they want to process another batch of vehicles. Then after reading and storing the input, it will check and proceed to the next step until it's done.
This algorithm outlines a process for managing a toll booth system, where vehicles pass through and toll fees are collected based on their type. Here's a step-by-step algorithm. Step 1. Start. The algorithm begins execution. Step 2. Initialize total amount to 0. A variable total amount is initialized to store the total fees collected. 3. Display vehicles, types, and their toll fees. Information is displayed to the user about the different types of vehicles and their associated toll fees. 1 motorcycle 50, 2 car 100, 3 bus 150, 4 truck 200. Step 4. Prompt the user to input the number of vehicles to process. The system asks the user how many vehicles they want to process for toll collection. Step 5. Read and store the number of vehicles. The system reads and stores the number of vehicles the user wants to process. Step 6. Check if number of vehicles is less than or equal to 0. The algorithm checks if the entered number of vehicles is valid, greater than 0. If the number is invalid, it will prompt the user to enter a valid number again. Step 7. Loop through the numbers of vehicles. The system will start a loop to process each vehicle, repeating the following steps for each vehicle. Step 8. Display processing vehicle X. A message shown indicating which vehicle is currently being processed. Step 9. Prompt the user to input the vehicle type from 1 to 4. The system asks the user to input the vehicle type from 1 to 4, which corresponds to the previously displayed toll fee structure. Step 10. Read and store the vehicle type. The system reads and stores the user's input for the vehicle type. Step 11. Check if the vehicle type is valid from 1 to 4. The algorithm checks if the entered vehicle type is valid within the range of 1 to 4. If the input is invalid, the user is prompted to enter a correct vehicle type. Step 12. Based on the vehicle type, update the total amount. The algorithm adds the appropriate toll fee for the vehicle type to total amount. For example, if vehicle type is 1, add 50 to total amount. Step 13. Display the toll fee collected for the vehicle. The system displays the toll fee collected for the specific vehicle. Step 14. After processing all vehicles, display the total toll fees collected. Once all vehicles have been processed, the system displays the total toll fees collected for this batch. Step 15. Prompt the user if they want to process another bunch of vehicles. The system asks the user if they want to process more vehicles. 1 for yes, 0 for no. Step 16. Read and store the user input. The system reads the user's decision. Step 17. Check if the input is 1 or 0. The system checks if the user entered 1 or 0. If the user enters 1, it will loop back to step 4 to process another batch of vehicles. If the user enters 0, it moves to the next step. Step 18. Display tool boot ended. The system display a message indicating that the tool boot process has ended. Step 19. End. The algorithm ends and the program terminates.
Pseudocode. Pseudocode is a simplified, informal way of describing a computer or algorithm using plain language or structured formatting. In our pseudocode, it outlines a program designed to process tool fees for different types of vehicles. In our variable declaration, we use the variable total amount to declare as a double, which will store the total tool fees collected during each batch of vehicle processing. We use outer do-while loop to repeat until it falls. Loop is initiated, meaning it will continue independently until explicitly broken. In our initialization, inside the loop, total amount is initialized at 0 at the start of for each batch. And we display the type of vehicles. The program prints a list of vehicle types along with their associated tool fees. For the input per vehicle count, the user is prompted to enter the number of vehicles to process. If the input number of vehicles is not a positive number, a while loop repeatedly asks for a valid input. In our processing, a for loop iterates from 0 to number of vehicles to -1 to process each vehicle. Vehicle type input. In our vehicle type input, inside the loop, another do repeat structure prompts the user to input the vehicle type 1 to 4. If an invalid input is given, it displays an error message and prompts again until a valid choice is made. In our tool calculation, we use switch. A switch statement determines the tool fee based on the vehicle type. 1. Motorcycle adds 50 to total amount, which is 0. 2. Car adds 100 to total amount, equals to 0. And 3. Bus adds 150 to total amount, equals to 0. And 4. Truck adds 200 to total amount, equals to 0. After each case, a confirmation message is printed indicating the vehicle type and tool fees collected. Displaying tool fees. Once all vehicles in the batch have been processed, the total fees collected for that batch are displayed. And for the batch continuation prompt, the user is asked if they want to process another batch. Type 1 for yes and 0 for no. A while loop checks for valid input and repeats until a correct value is provided. In our termination, if the user inputs 0, the loop breaks, and the program concludes by printing toolboot ended. Our pseudocode effectively manages user input, vehicle type validation, and tool fee calculation, while allowing for multiple batches of vehicle processing. That's all.
This flowchart illustrates the vehicle cost calculator process. It begins with a start point, where the program initializes a scanner and set the total amount to 0. The program then displays the vehicle types and prompts the user for the number of vehicles. It checks if the number of vehicles is greater than 0. If not, an error prompts the user to re-enter the value. For each vehicle, the user specifies its type, which must be between 1 and 4. Invalid input results in an error message and a prompt to try again. Upon valid input, the program adds costs 50 for type 1, 100 for type 2, 150 for type 3, and 200 for type 4, displaying a confirmation for each addition. After processing, the total amount is displayed, and user is asked if they want to process another batch. If the input is invalid, an error prompts for re-entry. Choosing to end the process concludes the program, while choosing to continue loops back to reset the total amount and restart.
our code explanation, the code implements a tool processing system for different vehicle types. Here's a breakdown of its functionality. The code begins by importing Java Util Scanner class for user input. The main class is named Midterm project. The entry point of the program is the main method. A scanner object is created to read input from the console. We use do while for outer loop. Do while for outer loop. This is to allow the user to process multiple batches of vehicles. Vehicle type display. The program displays the types of vehicles along with their corresponding toolpiece. For the motorcycle, the fee is 50, for the car is 100, and the bus is 150, and the truck is 200. For input for numbers of vehicles, the user is prompted to enter how many vehicles they want to process. And a while loop ensures that the user inputs a positive number. For processing each vehicle, a for loop iterates over the number of vehicles specified. Inside this loop, another do while is used to ensure valid vehicle type input from 1 to 4. And for the switch, a switch statement handles each vehicle type and update the total amount accordingly while providing feedback. For the total collection output, after processing all vehicles, the program prints the total toolpiece collected for that batch. For the continuation prompt, the user is asked if they want to process another batch of vehicles. 1 for yes, and 0 for no. And another while loop is prompt here to ensure valid input for continuing or existing. For the end of program, if the user opts not to continue, the loop breaks. This one. The loop breaks and a message indicates the end of the tool boot session, which is this one, tool boot ended. Finally, the scanner is closed to prevent resource leaks. This code effectively manages toolpiece, processing for multiple vehicles, validating user input, and calculating the toolpiece, and allowing repeated processing.
For testing and debugging, test the program with various input cases and invalid input to test the program to ensure robustness. To test the program, test with a variety of valid vehicle types 1 to 4. Input a reasonable number of vehicles, example 1, 5, or 10. Enter 0 or a negative number when asked how many vehicles to process. Try entering an invalid vehicle type, example 0 or 5. After processing a batch, test the option to process another batch by entering both 1 yes and 0 for no. Input a mix of vehicle types and check that the total amount is calculated correctly. Enter non-integer values like letters and verify that your program handles exceptions properly. For debugging, you can test it by you can add print statements at various points in the code to track variable values like total amount, number of vehicles, or vehicle type. And for input validation, consider wrapping input statements in a try-catch block to handle exceptions for non-integer inputs. Ensure that the do-while loops are functioning as expected. For example, check if they are entering the loop when they should be and breaking correctly. For total calculation, after processing a batch, print the intermediate totals after each vehicle is processed to ensure the correct amount is accumulated.